Welcome to this explainer. You know, a modern AI data center can easily consume as much power as an entire small city. It's wild. So today we're going to break down exactly how you manage that massive, power-hungry beast. We're exploring how a platform called SuperCloud Composer acts as the ultimate conductor for the incredibly complex orchestra that is the modern data center. If you've ever wondered how operators keep thousands of servers, smart power grids, and advanced liquid cooling systems working in total harmony without things literally melting down, well, you are in exactly the right place. Let's get into it.
Here's our quick roadmap for today. We'll start by unpacking the data center dilemma, then introduce SuperCloud Composer. After that, we'll dive into its lifecycle architecture, look at how it actually tames AI SuperClusters, and finally, wrap up with advanced monitoring and analytics.
Section 1. The Data Center Dilemma. To really appreciate the elegance of this solution, we first need to wrap our heads around the sheer scale of the problem facility operators are dealing with right now.
Modern data centers are just under unprecedented pressure. Organizations are practically forced to juggle multiple generations of compute, storage, and networking hardware simultaneously. And on top of that, they are rapidly scaling up for these incredibly dense AI-driven workloads. When you run AI, the heat and power density required is just astronomical. The real nightmare starts when you try to oversee these hypermodern, liquid-cooled environments using outdated, rigid tools. Honestly, it's like trying to fly a modern commercial jetliner using the dashboard of a 1990s sedan. You just don't have the dials, the gauges, or the deep visibility you need, which means you're basically flying blind into highly volatile territory.
And this contrast perfectly highlights why those traditional models are failing us. They rely on these rigid, tightly coupled architectures that inevitably cause critical blind spots, underutilized resources, and rapidly skyrocketing power and cooling costs. Shifting to a modern platform like SuperCloud Composer changes the game completely by giving you a unified operational control plane. Sure, that sounds a bit like industry jargon, but simply put, it means you're finally trading in a dozen messy, fragmented software tools for one single automated dashboard that seamlessly talks to absolutely every piece of hardware in your facility. The operational overhead you save is massive.
Section 2. Enter SuperCloud Composer. So, how do we actually bring harmony back to these sprawling, chaotic operations?
The crucial concept to grasp here is that SuperCloud Composer, or SCC, is definitely not just another basic server monitoring tool. It's a comprehensive, unified gateway for your entire data center. It oversees the complete infrastructure lifecycle across physical, virtual, and cloud environments. We break this down into Day 0, Day 1, and Day 2 operations. So instead of duct taping together different tools as your hardware ages, SCC serves as the single overarching platform that governs a machine from the very second it's plugged in, all the way until the day it is finally decommissioned.
Imagine getting a centralized login to manage your entire physical and virtual landscape from a true single pane of glass. Think about the daily friction an IT admin deals with. With this, you are no longer constantly jumping between 10 different clunky interfaces. No more wrestling with multiple passwords just to check a server's health, verify a switch configuration, and then completely log out to check the room's cooling unit. It's all brought together seamlessly, right in front of you. That jarring context switching is completely gone.
So what makes this unified approach actually tick under the hood? Well, SCC relies heavily on a standard Redfish API. If you aren't familiar, just think of Redfish as the universal translator for data center hardware. It lets the software securely talk to almost any modern server component, no matter who manufactured it. And because it has that deep, universal access, it unlocks massive physical feature sets like integrated liquid cooling visibility and automatic leak detection. SCC instantly translates these deep technical capabilities into business-saving actions. For example, if a cooling line springs a leak, the system can automatically enforce a power shutdown to that specific rack, stopping a catastrophic hardware failure before a human operator could even react.
Section 3. Lifecycle Management and Architecture. Let's shift gears and look at how this platform practically operates across those Day 0 to Day 2 lifespans we just mentioned, plus the back-end architecture that makes it all possible.
Let's walk through a little mini story of an IT operator's week. Imagine unboxing 100 brand new servers on a Monday. That's your Day 0. The platform instantly kicks off rapid physical asset discovery, automatically finding and inventorying your new racks, switches, and power units the exact second they hit the network. Tuesday rolls around, day 1, and you move straight into bare metal OS provisioning, seamlessly pushing out operating systems and policy-based configs to all 100 machines at once. You don't have to touch them individually. Finally, you enter day 2, which is where those servers will live for the next 3 to 5 years. Here, you're relying on deep time series analytics, event logging, and telemetry to continuously monitor their health, update firmware, and keep the whole show running flawlessly.
Now, behind the scenes, this entire orchestration system needs to be absolutely bulletproof. SEC services are deployed on a highly available Kubernetes-based backend. Why does that matter to you? Well, Kubernetes uses isolated, self-healing containers. If a single monitoring service inside the software happens to crash, Kubernetes instantly restarts it in the background. It doesn't take down your whole management dashboard. Basically, your management platform becomes just as resilient, robust, and scalable as the multi-million-dollar physical infrastructure it's controlling.
Section 4. Taming AI SuperClusters. Let's zoom in on what is arguably the most demanding, fascinating environment in tech right now: generative AI and large language model infrastructure.
Managing massive AI deployments is notoriously complex, but the AI SuperCluster module simplifies it beautifully. When you're building large-scale AI clusters, you are dealing with an absolute beast of technology. This unified approach brings all the related components, things like high-speed NVLink switches, ultra-dense compute trays, and massive power shelves, into one highly organized inventory. So instead of manually cross-referencing 3 different spreadsheets to figure out which power supply feeds which GPU node, you get a perfectly clean view that highlights the exact operational health and state of every connected component in real time.
And this deep integration is absolutely critical because AI nodes don't just run hot, they run hot enough to rival industrial ovens. Standard air conditioning simply can't keep up anymore. So liquid cooling is the new standard. SCC extends way beyond traditional server metrics here, giving you deep liquid cooling oversight. We're talking everything from the facility's main water loop right down to the microscopic cold plate sitting directly on the silicon chips. It's constantly monitoring coolant flow, pressure, and temperature telemetry. This lets the system spot thermal hotspots and intervene way before they throttle your processing performance. It's essentially an automated, policy-driven safety net for your massive AI investments.
Section 5. Advanced Monitoring and Analytics. Finally, let's zoom all the way down from those macro-level policies to the micro-level analytics that operators rely on every single day to keep the digital world spinning.
The POD View module gives you this really intuitive, aggregated look at system health across radically different environments. Now, a pod is basically a cohesive block of compute, network, and storage resources grouped together. Whether your workloads are running in a tiny edge data center halfway across the country or sitting in a massive centralized core facility, this gives you rapid situational awareness at a glance. You can immediately see if your Kubernetes pod, storage pod, or liquid-cooled AI factory has any critical warnings or power anomalies. It takes thousands of complex data points and boils them down into simple green, yellow, or red status indicators.
But when an issue inevitably pops up, you need specific details and you need them fast. You can instantly drill down from that high-level dashboard straight into specific individual system health. You can inspect component-level status, check individual memory slots, and review exact baseboard management controller or BMC events. Think about the real-world stakes for a second. Instead of sending a technician to wander around a deafening, freezing server floor trying to hunt down one tiny blinking red light, you can isolate the fault and troubleshoot the entire issue right from your desk. And you do it all without losing the broader context of where that machine physically sits in the room.
To squeeze every last ounce of value out of that hardware, the platform hooks you up with deep time series charts. You can monitor exact real-time performance metrics, like your processor bandwidth usage, along with historical minimum, maximum, and average views across your entire heterogeneous environment. Having this objective data ensures you're maximizing resource utilization, accurately forecasting your capacity thresholds, and proactively upgrading hardware well before you ever hit a performance bottleneck that actually impacts your end users.
As data centers continue to scale up into these massive, incredibly power-hungry AI factories, the margin for human error is rapidly shrinking to zero. The complexities of power generation, thermal dynamics, and raw compute are colliding at a scale we've literally never seen before. So the question we're left with isn't just how we'll physically build the supercomputers of tomorrow. It's whether, without unified orchestration and true, deep visibility, we will even be able to control them. Thanks for joining me on this explainer.